Now let us look at few example programs in embedded C. So our assignment number 1 is write down an 8051C program to send the values from 00H, that is hexadecimal numbers, to FFH to port 1. Now here in this case we can observe that we have to send the values between 0 to 255. All these values are positive values. So we can go with the data type unsigned char. So that is the most important thing that we have to remember. You can visualize the hardware by using your diagram. Look at the hardware in which we have connected 8 LEDs to the port 1. So they are connecting from port 1.0 to port 1.7. So when we pass the data, that is 00S to FFH, it will work as a binary count. Now here is the program for assignment number 1. Just go through it and then I will explain this program. So as I told you, this starts with hash include. So we are using this program for 8051. So we have to include a header file named as regx51.h, followed by void main void, which is the topmost function in an embedded C. After that we have to use a while one. So as you know that this is called as a super loop. So this is the topmost loop in the C program, and after that we have to declare a variable unsigned char and its name is Z. As you know that unsigned char means we can range a value from 0 to 255. Now we have to repeat this from 0 to 255. So I am going to use a for loop for that. So I am going to initialize for loop by using is equal to 0, Z is less than or equal to 255 and Z plus plus. As we know that in a for loop, the first is called as an initialization condition, the next one is called as a condition need to be checked, and next to that is a parameter need to be incremented or decremented. So here when I execute the program, what happens is that first of all the value of Z will become as a 0. Then the for loop will check whether the value is less than or 255 or not, and if this condition is false, then Z plus plus means it will add 1 to it. It means that the value of Z will be incremented by 1. After that, the value will be passed to the port 1. So once again, it will check whether the value is less than 255 or not, and this loop will repeat and repeat for 255 times. So once it becomes 255, then this condition is false and it will go to the while one. So once again the counter will start from 0 to 255. So ultimately what we are going to look at is, if you look at the LEDs, you will see that it works as a binary counter. This program, now let us run this program on a Microvision compiler and try to look at the output. Before running your program on a Microvision compiler, please look at the tutorial how to run a program on a Microvision IDE. That is a separate tutorial. You can download all these programs. I have given the link down in the description. Let us go to the Microvision compiler. So here is a Microvision compiler in which I already load the code. So I'll start this code right now. So here you can look at the code. It's include regx51 file, which means that the code is written for 8051, and after that we have a void main void function, which is the topmost function in a C. After that we have a while one, which is nothing but a super loop, and after that I have declared one variable with the data type unsigned char. So in unsigned char we have the values from 0 to 255. Now to repeat this statement 255 times, I have used a for loop, which is nothing but a looping statement. So I initialize this variable Z is equal to 0. Then I check whether the value of Z is less than or 255 or not. And after that, with each loop, the value of Z will be incremented by 1. After this, the value of Z will be passed on to the port 1. So when I start this program, what happens is that, first of all, Z becomes a 0. It is less than 255. So the value will be passed to the port 1. After that, the value will become 1 and it is still less than 255. So once again it will be incremented by 1 and the value will be passed to the port 2. Now let us simulate this program. You can simulate this program by clicking on debug window and after that start stop debug session. So it will pop up on warning. It says that the limitation is 2 KB. Our program is less than 2 KB. So let us click on the OK. Now here you have to look at the pointer. So this pointer will tell you which statement is running right now. Now to visualize the ports, we have to go with the peripherals, and from IO ports we have to take out the port number 1. So here you can see that once you restart your microcontroller, all the ports are by default output port, and all the ports are having value of 1. So that is why it is saying 0xFF. So this right click means those are having value of 1. So let us run our program in a step-by-step mode. So here is an option by which you can run your program step by step. So let us click on this. So you can see that right now the value has been become 0. So at the bottom also you can see that the variable z has been defined. Right now its value was 0 before execution of the program, and I am right now running it, so it becomes 1 and it is unsigned char. Okay, so let us run. So it become 1, then 2. As you can see over here, it's a binary counter, so it is 1 and 0. Now when I click on this, this becomes 1 and 1, which is nothing but a 3. Now once again I will run it and it will become a 4. So that is 1 0 0. So bit pattern is like this: 0 0 0 0 0 1 0 and 0. So wherever there is a right click, it means it's a logic 1 and the rest are logic 0. So let us run. So 5 6 7 8, and you can go ahead. Even you can run this program in a continuous fashion. By clicking on this icon, you can run this program in a continuous fashion, but we won't be able to see a binary counter because it runs very fast. So I'll click on this. Let us check out the output. Okay, so this is how it works. So by clicking on this red icon, you can stop the execution of the program. So I will click on this. At any point of time, I can stop this program. So right now it is DC. Okay, now let us run this by step by mode, and it will become DD, DE, DF and E0. So it's a binary counter. After this, we have to stop the debug session so that we should come in an editable area, and then we can load a new program to this. So I'll remove this file right now so that next time I should include the new file. Are you want to sure? You have to press yes. Let us look at this program in another way. Okay, so what we are doing is we have made a binary counter, but let us say that I want to observe port 1 and I want to see in the form of the waveform. Now what I mean is like this: we have already developed a program and we have a 0 errors and 0 warnings. So let us go to the debug window and start stop debug session, and let us put at OK. Now what we have seen earlier is that we have taken a peripherals, and from the peripherals we have taken a port 1 and we have visualized this as a binary counter. Now what if I want to visualize this as a waveform? So there is one more facility in a Microvision compiler. That facility is over here. You can click on this and it says we have the logic analyzer. So sometimes you need to trace the waveform. So in that case, this tool is really very important. So you have to click on this. So once you click on this, we have to go to the setup. And once you go to the setup, we have to monitor the port 1. So here I have already declared it, but you want to declare it. Then what you have to do is, so I'll first of all delete this. And from this icon, you can add any port or the port line. So you click on this and in the capital write down P and 1. The word P should be capital, and then only it will work, and you just say close. So here you can see that the port 1 is available. Now let us run this program and look at the output. So I'll run this program in a stepwise mode. Okay, so here you can see that it's a binary counter, as well as you can look at the waveform over here, which is incrementing. So it will increment up to 255, and after that it will become a 0. So slowly you can see that it's incrementing, and it will reach to 255 and it will become a 0. So it will become a sawtooth waveform. How? Now let us run it continuously. So I'll press on this button. So here you can see that it's just nothing but the sawtooth waveform. So once it is reached to 255, so here you can see that once it is reached to 255, it will become a 0. So yeah, 255 it becomes a 0. So you can click on at any point to check out its value. So this is a really a good tool to observe your output. So I think for this session we'll stop over here. So every time you have to stop the debug session and you have to come back to the editable area.